More horizontal asymptotes. This looks like an interesting function. It looks complicated, but it's not. And this is what we will see. So the first thing I want to do is I want to manipulate the function a little bit. And the first thing you'll notice here is that they give you a very simple task of adding x and 2x. I think this will give us 3x, if I'm not mistaken. So the bottom line is that they really try to give you complicated expressions, or well, they're not complicated, they just seem to be complicated. But in reality, they're not. You just need to be patient. So here I did 2 plus 1, that's 3, I think. And I have a multiplication by 1 over x here. So I hope you don't mind if before I distribute it, or maybe let me distribute it actually. Let me distribute it. So I'll get 1 over x times this thing. Times this very big thing, plus 1 over x times x, plus ln of x times 1 over x. So I think also x times 1 over x gives us 1. Here there's not really much we can do, so I'll just leave it as it is. As for the first expression, well, notice that this is a multiplication of 2 terms. The second term has a factor of x, so we can write this actually as x times x plus 3. And very luckily, we have another x to cancel it out with. So this is x times 1 over x, so it gives us 1 again. But I will not write this part down, I'll just do like this. I hope that is okay. I'll use the same color. And then I have something that's fairly more reasonable, which looks like the following. X plus 3. This is just 1. But then it actually goes on. Because by the property of logarithms, if I have, let's say, logarithm of a, and I'm adding that to the logarithm of b, then this is actually equal to the logarithm of a times b, which is cool. Why do I say that it is cool? Well, it's just a personal opinion in the first place, and it is also because if we apply this here, we precisely get ln of 1 over x times x. So again, ln of a plus ln of b is ln of a times b. ln of 1 over x plus ln of x is ln of 1 over x times x, which cancel out to give us ln of 1. And the second property is that ln of 1 is actually equal to 0, because the ln function really asks. So if I tell you why, if I ask you why ln of 1 is 0, it's because 1 is the number we get. 0 is the number we plug in to get 1 out of the exponential function. So the natural logarithm and e are like dual objects. They're like enemies. They're actually inverses. I don't need to give analogies. They're actually inverses of each other. So if I want to find ln of 1, then I'm looking at the x, which makes e to the x be equal to 1. And in that case, this is of course 0. I hope that is clear. Well, that's good news, because this is equal to 0, and this is being multiplied by x plus 3. So this is all going to be equal to 0. I hope that is okay. Then we're adding 1 and then ln of x times 1 over x. And I hope in the midst of all of this chaos, you've not forgotten how to find a horizontal asymptote. And the way to do this usually is, if we have a function which has an asymptote, then this function is bounded by some line, either from above or from below. And the only way to find out is to check. You have to walk on the x-axis infinitely to the left and infinitely to the right, and look upwards to see if the function breaks the ceiling or if it stays in it. So if we take the limit of the function as we go to infinity and minus infinity, and we get a constant, then this constant is the horizontal asymptote. That is more or less a good way to think about it. I'll leave this graph to you here. I was not planning on writing this down. I think I just improvised. But it looks nice, so I'll leave it. We're looking at the limit as x tends to plus or minus infinity of y of x, which is simply equal to 1 plus, after the simplifications, 1 plus ln of x divided by x. Well, if we distribute the limit, the first one is just 1, because 1 does not change as x changes. And then we have the limit as x tends to plus or minus infinity of ln of x divided by x. And this is a race. We're going to infinity, and we want to know who will reach infinity first. Who grows faster? Is it ln of x, or is it x? And in that case, it is actually x which grows faster. We've discussed this. So the ln function grows slower than any polynomial, and x is one of those polynomials. X is just a monomial, actually, because it's just one term. Yeah. So in that case, x wins the race, and we go to 0, because you're dividing a small number by a very big number. And so we get 1 plus 0, which I think is, I was going to say 0, but now I've changed my mind. I think the answer is 1, but I might need to check. So just give me a moment.